Suppose we tested n number of subjects for our disease X, and the data is presented in the form of a 2 by 2 table. In this table, the columns named as yes and no represent the true status of the subjects for the disease as determined by gold standard, and the rows named as positive and negative represent the results of our screening test, which is designed to detect the subjects with the disease X. Now, first of all, let's try to understand the sensitivity of this screening test. We can define sensitivity as the probability of a positive test result, provided that the disease is present. So the provision here is that the disease is present. It means that we are not interested in all the subjects. We are only interested in the subjects with the disease, and these subjects are represented by the sum b plus c in 2 by 2 table. Out of these a plus c subjects, our test could identify only a number of subjects for the disease, or we can say that the test results were true positive for a number of subjects, but it couldn't detect C number of subjects for the disease. Or we can say that our test results were falsely negative for C number of subjects. And we can compute the sensitivity of this test by dividing the number of true positive test results by the sum of true positive and false negative test results. Now, let's try to understand the specificity of this test. So we can define specificity as the probability of a negative test result provided that the disease is absent. So the provision here is that the disease is absent. And again, we are not interested in all the number of all subjects. We are only interested in the subjects without the disease, and these subjects are represented by the sum b plus d in the table. Out of these b plus d subjects, our test results were negative for d number of subjects, but were falsely positive for b number of subjects. Now, we can compute the specificity of this test by dividing the number of true negative test results by a sum of false positive and true negative test results. Now that we have talked about sensitivity and specificity of the test, let's explore the predictive values. The positive predictive value is the probability of presence of disease in the subject, provided that the subject has a positive test result. So the predictive value positive is equal to the joint probability of presence of disease and a positive test result, given that the disease is present, and dividing it by the probability of positive test result. So the joint probability of disease presence and positive test result can be found out by multiplying the sensitivity of this test with the prevalence of disease in the general population, or the prior probability of disease in the subject. From the 2 by 2 table, we can see that the test can be positive for both diseased and disease free subjects. So the probabilities of positive test for both these groups will be taken into consideration while calculating overall probability of a positive test result. So the probability of a positive test result for diseased subjects can be calculated by multiplying the sensitivity of the test by the prevalence of disease in general population, or prior probability of disease in the subject. Of positive test result in disease-free subjects can be defined as the product of probability of a positive test result in subjects who do not have the disease and probability of absence of disease. Or in other words, we can say that the probability of test result to be positive, given that disease is absent, can be defined as 1 minus specificity of the test, and probability of absence of disease can be defined as 1 minus prevalence. Similarly, the predictive value negative is equal to the joint probability of absence of disease and specificity of the test divided by the probability of a negative test result. Again, from 2 by 2 table, we can see that the test can be negative for both diseased and disease-free subjects. So probabilities of a negative test in both these groups will be taken into consideration while calculating the overall probability of a negative test result.